Today we are working on Pythagorean theorem, and before we start Pythagorean theorem, we are going to talk about simplifying radicals. So Pythagorean theorem has been known for a long time, even before the Greek mathematician Pythagoras, who it was named for. So first off, when we are dealing with square roots or radicals, we are going to have to simplify them. So another word for square root is a radical. And to factor your radical, which is your number under the square root, we need to factor the number under the radical, which is your square root, into your factors so that you have one number that is a perfect square. And what I mean by perfect squares is 2 squared is 4, 3 squared is 9, 4 squared is 16, 25 squared, or sorry, not 25 squared, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, and 20 squared is 400. So these are the ones that you really need to know, and having them memorized will help you a great deal with this unit. So we've got examples here of what I mean by factoring into a perfect square. So you take 27 and you factor it, and it factors to 3 and 9. 9 is our perfect square, so we take the square root of 9 times 3, break it into two separate things, and the square root of 9 is 3 because 9 breaks down to 3 squared, which is 3 and 3. So one of those 3's comes out of the radical. Then we have the square root of 32. Again, break it down so that you've got a perfect square. So we've got 2 and 16. 16 here is our perfect square. So we've got square root of 16 times 2. We can break those into two separate things. And the square root of 16 is 4 because 16 breaks down to 4 and 4. And leave the 2 under. So my recommendation on these is always check 2 and 3 first, with the exception of I think 1 or 2 of our examples or 1 or 2 of our problems. It's always going to be a 2 or a 3. So check 2 and 3 first to see if they give you your perfect squares. So on our next example, we've got the square root of 75. So 75 is not divisible by 2, but it is divisible by 3. And 3 times 25 gets us 75. And 25 is a perfect square. It factors into 5 and 5. So that means we have the square root of 25 times the square root of 3. And the square root of 25 is 5. So we've got 5 square root of 3 being our answer for number 1. Number 2, take the factors of 18. 18 is divisible by 2. And 18 divided by 2 is 9. 9 is a perfect square. And 9 factors into 3 and 3. So we've got the square root of 9 times the square root of 2. And remember, square root of 9 is 3. So we've got 3 square root of 2. Next up, we've got 108. 108 is divisible by 2, but that gets us 54. 54 is not one of our perfect squares. So then we need to check 3. And 108 divided by 3 is 36, I believe. And 36 is a perfect square, and that breaks down to 6 and 6. So we take the square root of 36 times the square root of 3, and the square root of 36 is 6. So we've got 6 times the square root of 3. Our next one, we're taking the square root of 48. So we are going to divide that by 2, and 48 divided by 2 gets us 24. It's not one of our perfect squares. So then we're going to divide by 3. And when we divide by 3, that gets us 16. And 16 is a perfect square. Factors into 4 and 4. So we've got the square root of 16 times the square root of 3. So the square root of 16 changes to 4. And so we've got 4 square root of 3. Our next one, 50, is divisible by 2, and we get 25. And 25 is a perfect square. Remember, the factors for 25 are 5 and 5. So we've got 25, the square root of 25 times the square root of 2. And the square root of 25 is 5 times the square root of 2. Next one, we have square root of 98. And 98 is divisible by 2. It gets us 49. And 49 is a perfect square because it's 7 times 7. So we've got the square root of 49 times the square root of 2. Square root of 49 is 7, so we've got 7 square root of 2. Now, I know some of you who are working online are going, well, how do we type in the square root? So you've got 2 ways to do this. For this first one, so 5 square root of 3, you can type in 5 and then parentheses SQRT, parentheses 3, double parentheses. So that tells me that we're multiplying our square root times 3. The other way you can do this is 5 and then press the multiplication symbol on your keypad and then square root, SQRT, parentheses 3, close your parentheses. So most of the time you're going to have to do that when you are on the Edge Elastic website. There should be a drop down that will let you just use a square root symbol instead of having to type in square root. So next up, we're looking at fractions, and fractions are not proper if there is a radical in the denominator. So if you have a square root in the denominator, we have to simplify it. So in order to get that radical out of the denominator, we have to multiply by a special number 1. And that special 1 is always going to be that radical in the top and the bottom, in the numerator and the denominator. So we're going to multiply by the square root of 2 over the square root of 2. So we're multiplying across. That gets us 12 times the square root of 2 over the square root of 4. Now the square root of 4 is 2, so we've got that equals 12 square root of 2 over 2. Now 12 is divisible by 2, so we can reduce that further to 6 times the square root of 2. Our next one, again, we're going to multiply it by our special number 1 by square root of 2 over square root of 2. Again, still multiplying across, so we have 7 square root of 2 over the square root of 4. Square root of 4 is 2, so we've got 7 square root of 2 over 2. And 7 is not divisible by 2, so that's our answer for that one. Our next one, we have 5 over the square root of 3. So this time, instead of multiplying by the square root of 2, we're multiplying by the square root of 3. And again, still multiplying across. So we've got 5 square root of 3 over the square root of 9. And the square root of 9 is 3. So we have 5 square root of 3 over 3. The next one, still multiplying by the square root of 3 over the square root of 3. And again, still multiplying across. So 9 square root of 3 over the square root of 9. And the square root of 9 is 3. So we've got 9 square root of 3 over 3. And 9 is divisible by 3. So we've got 3 square root of 3. Now again, some of you who are working on the computer are probably going, how do I type in these fractions? So if you're going to type in that 7 square root of 2 over 2, what you need to do, same thing we did up top, but you need to start with a set of parentheses. So you have parentheses, 7, tell me that you're multiplying in some manner, if it's a multiplication symbol or a set of parentheses, SQRT for square root, open parentheses, 2, double parentheses because we're closing that first set, and then press the divide sign, and then 2. And that's how you would type in 7 square root of 2 over 2. Again, if you're working on the review or on the test in Edulastic, you will end up being able to type in a fraction and type the square root symbol just like you would on the calculator. Next up, we have Pythagorean theorem. Remember, Pythagorean theorem is a squared plus b squared equals c squared. When we are working with right triangles, which is this whole unit, I want you to label your hypotenuse first. So across from your right angle is your hypotenuse. Today you can just label it C. Later on in the unit, I will want you to write hypotenuse. It's going to be important that you label your hypotenuse all the time. It helps to reduce confusion on what all you are looking at. Okay, so we're going to use the Pythagorean theorem now. And something else about Pythagorean theorem, anytime you have 3 numbers that for Pythagorean theorem that are all whole numbers, and they're not 0, that's called a Pythagorean triple. So our first one, we need to label the side across from our right angle, and that's x, and that's our hypotenuse. So that's C, or you can label it as HYP for hypotenuse. So that is C. The other two sides are A and B. It doesn't matter which place you put those in. So we've got 3 squared plus 4 squared equaling x squared. 3 squared is 9 plus 4 squared, which is 16, equals x squared. 9 plus 16 is 25, equals x squared. And then we're going to take the square root on both sides. So we get x equals 5. Our next one, we want to again find the value of x, but this time round to the nearest tenth. So again, across from our right angle is our hypotenuse, so that's C. So again, we're going to set it up. 9 squared plus 15 squared equals x squared. 9 squared is 81, plus 15 squared is 225, equals x squared. 81 plus 225 is 306. And then we're going to take the square root of both sides. And we are going to put that in the calculator because we are rounding to the nearest tenths place. So the square root of 306. So we get 17.4929. And again, rounding to the tenths place. So that is going to be 17.5. And then our next one, we are, again, across from our right angle is our hypotenuse, so that's C. So again, we're finding x. 2 squared plus 2 squared equals x squared. So 2 squared is 4, plus 4 equals x squared. So that gets us 8 when we add those together. And we're going to take the square root of both sides. Now this time, we are not going to put this in the calculator because it asked us to simplify the radical. That means we need to take and factor this so that we have a perfect square. So when we divide by 2, we get 4. 4 is a perfect square. So we've got the square root of 4 times the square root of 2. And the square root of 4 is 2. So we've got 2 square root of 2 equaling x. Next up, we have the converse of Pythagorean theorem. Anytime you have a right triangle, you know a squared plus b squared equals c squared. That's what we've been dealing with. That's what you've learned already. When you have an obtuse triangle, your c squared is going to be greater. So that's a squared plus b squared is less than c squared. So c squared is larger. Opposite of that, if we have an acute triangle, a squared plus b squared is going to be greater than c squared. That c squared is going to be smaller. So now we're going to use that. But first we have to remember how to determine if the numbers given are can form a triangle or not. And remember, that's adding the two smallest sides and seeing if the third side is greater. So on this first one, we're going to add our two smallest numbers, 7 plus 12, and that's 19, and 19 is greater than 16. So this can be a triangle. So we're going to keep going and see if it's a right, obtuse, or acute triangle. So 7 squared plus 12 squared, and I'm going to put a box because we don't know if this is greater than, less than, or equal to 16 squared. So 7 squared plus 12 squared is 196, and 16 squared is 256. So we've got 196 and 256. And 256 is larger, so c squared is larger. And when c squared is larger, we have an obtuse triangle. our next one, we're going to do the same thing. We're going to add our two smallest together. So 11 plus 18, and that is 29, and 29 is less than 34. So this is not a triangle. So we can stop there because it's not a triangle, so it can't be right, obtuse, or acute. Our next one, again, adding our two smallest. So 8 plus 11 is 19. 19 is greater than 13, so this can be a triangle. So we can keep going. Add 8 squared plus 11 squared. Again, putting a box because I don't know if it's greater than, less than, or equal to 13 squared. So 8 squared plus 11 squared gets us 185, and 13 squared is 169. And 185 is greater than 169. So when c squared is smaller, that means we have an acute triangle. And our last one, again, add our two smallest. 5 squared plus 12, or not squared, 5 plus 12 is 17, and 17 is greater than 13. So this can be a triangle. Then we can do 5 squared plus 12 squared. Put a box because we don't know if it's greater than, less than, or equal to 13 squared. And 5 squared plus 12 squared is 169, and 13 squared is also 169. So since these are equal, we have a right triangle.